Hello, welcome to our video on linear modelling. Linear equations can be used to model many real-life situations. We need to keep in mind when you're using a straight line model, and this might be new information for you, that the rate at which something is happening, for example, the cost per item, when you have a rate, you're always going to have a per, kilometres per hour, dollars per minute in a phone plan, or cents per minute. So the rate can be expressed from a graphical point of view as the, not as a, as the gradient. And the initial situation, so whatever happened at t equals 0 or right when you started the model, can be expressed as the y-intercept. Okay, let's look at some examples. With your linear modelling problems, you're going to get two main types of questions. The first one is a fixed rate plus a certain amount per hour after. This is how phone companies charge you for their calls, something like 25-cent flag fall it's called at the start of the call, and then 12 cents per minute afterwards, things like that. So the rate is in the second half and the fixed amount is going to be the y-intercept. The second example we'll do is more to do with rates and speeds with kilometres per hour. So looking at the first example, the company charges a fixed fee of $100 and $60 per hour for its product. It would probably be a service that they're charging for rather than a product, just looking at that. So it might be an electrician. They charge you $100 just to come out and then $60 per hour for however long they stay at your house. Find an expression relating total charge, C, to the number of hours of use, N. So in this example, they've given you the two variables, C and N, which is hours. If you aren't given that in the question, then you need to start by defining your two variables. So we've got C and N, and we have our total charge will be equal to $100 plus 60 times the number of hours. So it's 60N. If you weren't sure how to put this equation together, you could think about, okay, put in a number for a number of hours, say 5 hours. How much would I get charged? So it would be 60 times 5 plus the $100 flat fee. 60 times 5 plus the $100 flat fee. So that's how you've ended up with that. We could also write this equation in our y equals mx plus c form as 60n plus 100. Same equation, doesn't matter which way round you draw it. Part B, sketch a graph of the relationship. The y-intercept is going to be 100 and the gradient is 60. Remember up here we said the rate is the gradient. So we can start here and I would be using the gradient. It's going to be a positive graph. I'd be using the gradient, so go up 60 and across 1, 20, 40, 60 across 1, 20, 40, 60 across 1. And by now you should have a ruler so you can draw in your graph and join the lines. Okay, you'll notice that I haven't extended my graph past x equals 0. And that's on purpose. You can't have, what is our x value? Hours. You can't have -1 hours in this example. So we don't need to extend our graph down further. So start here at 0 hours and just extend out to the right. sketch graph, done. What would be the charge for 7 hours use? A couple of ways you can do this. You can use your graph and read it off the graph if you have continued your line up far enough. Or you could put in n equals 7. So that's the one I'm going to put here because it's easier for me. C equals 100 plus 60 times 7, which equals 540 altogether. Make sure you put a $sign for your final answer because it's saying what would the charge be? So you need to put it in dollars. How long was the product used if I was charged $80? So the cost or the charge is $880. 880 equals 100 plus 60 n. $770 equals 60 n. N equals 770 on 60, which is 12.83 repeating, and we know that is 12 hours. And if you convert 0.83333 into minutes, so divide it by 60, you end up with 50 minutes exactly. The question was asking us how long, so we need to make sure that we put it into proper time rather than 12.83. A second example here is an example using speed. So it says a tram moves at 40 kilometers an hour away from the city. A second tram starts 2 kilometers from the city and moves away, that should be away, at 40, I'm going to change that to 30 kilometers per hour, so it's different. Write an equation for the distance of each tram away from the city at time t hours. So we can start by defining our variables. Let d equals distance from city in kilometers, and let t equal time in hours. So the first tram, I'm going to call it D1, distance 1 for the first tram, is moving at 40 kilometers per hour. So this is the rate, it goes in as the gradient, 40 times t. Again, if you weren't sure, you could think about, okay, after 2 hours, how far has it traveled? So it's going to be 40 times 2, 40 times t. And there won't be a y-intercept, so it's just a rate. And the second tram goes at 30 kilometers per hour, so that will be 30 times t. But it starts 2 kilometers from the city, so we add on 2 kilometers there. Write an equation for the distance of each tram away from the city at time t hours, D1, D2, done. Thanks for watching the video.